Hey everybody, coming at you live from beside my house. Now for this video, it's going to be out in the bright sunlight. Now I have moved this camera, I have spent like 20 minutes moving this camera all over the yard, back and forth, because there's such a glare on it from the sun that I can't see anything. But the sun is needed in this video. Alright, so what I'm doing, lean you down here. I don't know if you can see it or not in the background, but I've got a rope. Whoop! I got a rope tied up right here. I've got a rope tied up from tree to tree. Alright. Now, the idea behind this is what I'm going to do is, for years and years and years, I've been wondering about setting up tarp shelters in the bright sun. And I've been wondering, because of the Georgia heat, I've been wondering about, is there ways of cooling a shelter? And I've been thinking about materials and how they work, and insulation and reflectivity and wavelengths and all that kind of stuff. So what I'm going to do today, and I think it's easier to set this up in the yard at home where I know I've got direct sun and I've got a little bit more control over this, because this is just going to be an experiment. And I'm not really worried about shelter designs. I'm more worried about configurations of shelters as opposed to the materials. Now, what prompted this is a comment I got, and I'm going to explain that. I'm going to set up 3 shelters, and the comment I got I'm going to explain on the 3rd shelter. So what I've got for this experiment for keeping cool, you know, cooling your hot tarp shelter, I got 3 mercury thermometers, alright, and I got some homemade tent stakes, a bunch of carabiners, and I have 3 grabber blankets. Now, the first grabber blanket is going to be set up with the green side facing the sun, just like you would, you know, any tarp shelter. The second one, I'm going to have the reflective side facing the sun, okay? Because I'm going to see if the sun, if the sunlight, sun rays, waves will bounce off and be reflected off and keep that shelter cooler. Now that was the original idea for the videos, to set these 2 shelters up, and I never got around to doing it because I thought, nah, it might be boring. Well, there's yet a 3rd shelter that is an idea that got the old wheels spinning from a comment someone made. It involves a grabber blanket too, and a camo moving blanket. Okay, so I'm going to show you that here in a minute. First off, I'm going to try my best. I don't know if I can or not. I'm going to try my best to set these shelters up and film them. I don't even know if the camera's going to pick it up because of the bright sunlight, but I'm probably going to have to aim towards the house as I set them up. So let's get the first one set up so we can get some shade underneath. All right, we're going to set up this first shelter. Now, the idea is just to set it up. And I mean, I'm not getting real fancy with tarp shelter configurations or shapes. I'm just doing a basic lean-to try to see what the temperature will be underneath it. Setup, that's just your typical shelter setup, lean-to, that you would set up and crawl under to be blocked from the sun. So let's scoot next door and put up one with the reflective side out. I got an umbrella over the camera and the viewfinder, so I can still only halfway see what I'm filming. I hope this ain't a horrible video, but the scientific process of it is what's going to be interesting. And I'll bet you, since I got the camera on autofocus, I bet you the silver part is going to make the camera go insane. All right, so there's the second shelter with the the reflective side out towards the sun. Now for the 3rd shelter, what could I possibly be thinking? Let's find out. All right, so I'm recording and I still can't see hardly anything in the viewfinder, so I hope this video films. Now, first shelter, okay, tarp, just a tarp shelter, green side up. Second one, reflective side facing out. And incidentally, when I walk in front of that one, I don't feel nothing, but when I walk in front of that one, it literally feels like an oven from the sun bouncing off it. Now, the third one, you may ask yourself, Dave, have you lost your mind? Because it is set up with, just like the first one, the green side up. Okay, now, here's where the comment comes in. Somebody stated on, I think it was 2 videos ago, I did the tactical cooler that had the reflective material on the inside. And they said, if you think about it, that bag is a cloth bag and it'll absorb water. So if you dip it into water, it can have the evaporative cooling process of the canteen. Now, these canteens, if you take these canteens with the type of material this is, it's got this fuzzy inner material and then the outer is some sort of something. I don't know. I don't know if it's nylon or polyester or a blend. I don't know if there's any cotton involved in the inside or what. But you can wet down the outside of this. You can have water in your canteen and wet down the outside of this. And there's some anomaly that I can't explain that's some kind of evaporative cooling process that in 15 minutes the water will cool on the inside. Okay, so now that's the comment that got me to thinking. Okay, so what I'm going to do is I'm going to take this heavy moving blanket, this camo moving blanket, and it's got some sort of a filling inside of it, and it's 2 layers with the insulating type material in it, or padding. And I'm going to wet this down with a hose, and it's going to simulate like if you dipped it in a creek or a lake or a river. And I'm going to lay it over the third shelter, all right? And then I'm going to put thermometers under all 3 and wait 15-20 minutes and see what they say. And then I'm going to wait 30 minutes and come back and see what they say. All right? Sound cool? So let's get it done. I hate that cat laid on here. Now that blanket weighs about 30 pounds wet. So I'm gonna put it on the one on the end over by the pole. Now, as you can see, if you choose this route, the weight of that completely collapsed it and pulled the rope over. So I had to put a stick there to prop it up and a stick on the inside because that blanket it absorbs so much water, it's so heavy. So what we're going to do now is we're going to put thermometers underneath each one and wait 15 minutes. So the sun's no longer directly overhead, but we have some sunlight. And for my purposes, all we need is 15 minutes. Okay. So, and we got a little bit, I can see a little shade underneath each shelter. So I'm just going to set these underneath each shelter in the shade and see if there's a difference. Now my guess is if this actually works, what you could do is either carry a bucket with you and continuously splash water on your shelter, or maybe set up a bucket overhead full of water with a drip line or a hole in it, constantly dripping, keeping it wet. So, but it may not be worth the effort, so we'll find out. The sun is no longer directly overhead, so I bet this test is going to be kind of inconclusive, but I'm on second shift tomorrow, so what I'm going to do is I'm going to leave all this stuff up, and I'm going to come out here around 11 or 12 o'clock when the sun's directly overhead and see what kind of a difference this thing makes. So it's cool. We got some big airplanes overhead. So let's see what these say. That looks like 88 degrees. 88 degrees Fahrenheit. Yeah, 88. All right, let's move to the next one. Now that first shelter was the one that had the wet blanket on it. This is the one that's got the reflective side out. Now that says 90 degrees. 90 degrees. So there's a 2 degree difference. That's pretty neat. All right, now this is the one that has nothing but just the green facing out. 90 degrees. All right, so what I'm going to do now, tomorrow, I've got all 3 of these set up. So I'm going to wait until the sun is overhead, and I'm going to wet that other blanket down on the end, and I'm going to wait until the sun's been over it and just bake in it. And then I'm going to check these 3 thermometers again. Now, so far, that's very interesting, because I would have swore that the reflective side out would have made a difference, but there was no difference. These 2 was 90 degrees. And then the one on the end down there was 88. Now, the only thing about it is I don't know if it was the fact that it was wet or the fact that that was extra insulation blocking the heat. So, I mean, I might have could have put a dry blanket over it. Matter of fact, before I wet it down, that's what I'll do. That's thinking, because the wet blanket is just so heavy and so messy, it should dry overnight. So what I'll do is tomorrow I'll come back out here when everything is, the sun's overhead, I'll check them then. Okay, we'll go that route, all right? We'll go with a regular tarp, reflective tarp, and an insulated tarp. How about that? All right, we'll be back out here tomorrow. All right, day 2, the sun's been overhead at least 4 hours. I've been monitoring the thermometers, and the results are astounding. Now, mind you, normally when I camp under the thick forest canopy, under a shade tree. I don't do much camping out in the open under the sun. So, but I always wondered what the sun would do to these tarps. And I've been monitoring these, and due to what I found, there is no reason to wet down the blanket. It doesn't matter. So let's go over here and take a look real quick at what I have found. Let's go over here. All right, now let's take a look at, let's take a look inside here now. This is just a normal tarp with the green facing out, okay? All you've got separating you and the sun is this tarp. Now let me say this. I don't know about in the direct sun, I didn't put the thermometer out, but our air temperature today is 88 degrees Fahrenheit. Okay, keep that in mind now, 88 degrees Fahrenheit. Look at this. That looks like 98 degrees. That's what I'm reading, 98 degrees. So let's go look at the next one. Now this next one is the one that the reflective side is out, facing the sun. Now this material works great in the wintertime for reflecting heat back towards you when you have a fire. And there was that rumor going around that everybody's like, okay, oh, you could turn this to the outside and it would work. Well, let's see if it does. 100 degrees. 100 degrees. How's that grab you? I'm just as shocked as you are. A regular tarp, 98 degrees. Tarp reflective side out, 100 degrees inside. Now let's look at the one that's got the cover over it. Okay, now this is on the outside. This moving blanket that's on the outside has dried up from the sun. It's no longer wet. Let's look at it. Oh man. It's like 96 or 97. It's like 96 or 97. Yeah, it's like 96. All right, now the thing is when you put your arm under here, you can very much feel that it's cool. So, I got 40 minutes left before I go to work, so I'm gonna try another experiment, okay? All right, I gotta leave in 40 minutes, so that gives me 40 minutes. So what I'm gonna do is I'm gonna put, this is a black Snug pack jungle blanket, okay? Keeps you warm in the winter. Well, why not carry it in the summer? Let's just cover up this shelter and see if this black insulated blanket drops the temperature in 30 minutes. All right, 30 minutes now. We got a black Snug Pack jungle blanket on top of our tarp shelter. I'm gonna come back out in 30 minutes and we're gonna check the thermometer to see if it makes any difference at all, because we got plenty of sunlight overhead. All right, 30 it's been exactly 30 minutes, okay? I gotta walk out the door and head to work in 10 minutes. So let's wrap this up. Quick recap. This is the shelter with the dry camo moving blanket on the outside. All right. And before I came out here, I looked and it's still 88-degree air temperature. No clouds in the sky, solid sun. So let's look, see. We are at about 97 degrees. .97 degrees. Now, let's go back to the one where the reflective side is out. Let's see. Reflective side out. Well, that's 102. 102 degrees Fahrenheit. Unbelievable. Wow. Okay, now next is the one that has the black Snug Pack jungle blanket. It's only been on 30 minutes. Let's take a look at this. 98 degrees, so it's the exact same as the camo moving blanket. So what am I gathering from this? Don't camp in the sun. And if you're willing to carry a blanket in the winter to stay warm, carry it in the summer to stay cool. And the reflective part, it doesn't reflect the rays back. Evidently it heats up the inside of the shelter. So this is day 3, and instead of wrapping up the video, I decided one more little experiment. After the little fiasco with the wet blankets and the dry blankets. So I came out here early and I have set up 2 more tarp shelters, pup tent style. Now that one back there is a single pup tent style tarp. Over here I got to thinking to myself, why cover it with a blanket? Is there a lighter weight option? So why not just set up 2 tarps with an air space? Okay. So now what I'm doing is I'm just waiting for the sun to come overhead, and I've got a thermometer in there, temperature gauge. I've got one laying in there, one's laying inside there, and then one's laying inside that over there. So we're going to see, and there's an air space between here. So we're going to see what if that does any kind of difference. I've also got a temperature, a thermometer on the other side, just laying on the grass so that I can see what direct sunlight, what the temperature of direct sunlight bearing down on you is. So this should be interesting. All right, the sun's been out hitting this now for about over an hour, well over an hour. It's gone behind the clouds now, which makes for good filming. So let's ease over here and check out our temperature gauges and see what they're saying. Now I have laid one out. I have laid one out directly on the ground, out in the sun. And it is 100 degrees Fahrenheit right now. Now it may get just a little bit hotter when the sun comes out. Our sun just came out. We'll check it again. Now we're going to check inside here. There's that glare. All right, I'm going to check inside this single wall pup tent style tarp. All right, so 92 degrees. All right, it's 100 degrees in the sun, 92 degrees Fahrenheit in the single wall tent. So let's ease over here now and let's take a look at the double wall tent. All right, now let's lower this down just a little bit here because there's something else that I want to show you while I'm here. All right, let's take a peek here now. Let's see if I can see real quick. What I want to do is I have an airspace here. Before I had, in other experiments, I had the tarp with a wet blanket, and then I had a tarp with a black Snug pack blanket. And what I have now here is an airspace. And I'm going to put my arm in here, and I'm just going to kind of get used to what this is. I'm going to feel of it. And then I'm going to put my arm in here. That's a little warmer. Now let's pull this back. What I have in here is I have a little temperature gauge in here. This is different from the other one, so let's read it and see what it says. 98 degrees Fahrenheit maybe. 98 probably, so that's in between here. That's what that air temperature is. Now, for the big test, is this 2 degrees cooler at least from that? 90 even. 90 degrees even. Now I can't remember what this one was. Let me reach under here and grab this one. Now what was the single wall? 92. Okay, so this proves the same thing I've been dealing with all along. Okay? For whatever given temperature of a single tarp, it does not matter if you put a wet blanket on top, it does not matter if you lay a dry blanket on top, it does not matter if you have an airspace with two tarps. You're going to get a 2 degree difference every time between these three setups and a normal tarp. And if you turn the reflective side out, it's going to turn like a human oven. Terrible, terrible, terrible. But I don't know. I've learned a lot from this. This is pretty interesting. So what are old Dave's conclusions? Old Dave's conclusions on this is, if you have to be in the sun, lay something over your tarp. There's no reason to have a blanket in hot weather like this. So just go ahead and bring an extra tarp and double it up if you want to. I'm thinking within reasonable thought that a triple tarp wouldn't matter. Airflow through it is pretty good through each side. You might want to put a bug net on each side. But in general, no matter what you do, you're not really going to get greater than 2 degree difference in the sun when you block the sun from coming at you. And my advice is any chance you get to set up under a shade tree, do it. So hopefully next video I'll be back out in the woods. Hope you enjoyed it. Hope you learned something. Maybe you've got some ideas that I didn't come up with. Set some stuff out in the bright sunlight. Set one up in the sun, set up one in the shade. For old Dave here, all my setups are in the sun. Thanks for watching, and I'll see you in the next one.